The 5.3 representing enthalpy changes. So we can have different ways of showing enthalpy changes. Example here is H2O water decomposes to the hydrogen and oxygen. It will absorb, for this reaction to absorb 285.8 kilojoule per mole. The molar enthalpy for this reaction. And you see, because it's positive, means it's absorbed. Here is exothermic, hydrogen combustion happen, react with oxygen, will give you water, so it release 285. The negative means is exothermic. So he's in this picture, you see the CH3OH plus O2, this is your reactant, and when it burn, it release energy, and your product have a lower energy level. The difference between energy levels of the reaction and product is the enthalpy change. Here, enthalpy change, you can show it as delta H. You just write the reaction and you show it as negative 726 kilojoule, or you can just write down then and put the 726 as product side. It means it's released, is in product side. There's like 3 different ways you can show the enthalpy: the diagram, inside the reaction, or just you have a reaction and just put it beside. So here's it again, just explain it. The thermal equation with energy term means the energy term is inside. Here is the energy absorbed, as you have it on the left side on reactant side. Your energy released is going to be on the product side. Okay, this is an example. Write a thermochemical equation to represent an exothermic reaction that occurs when 2 moles of the butane burn next to this oxygen gas. The molar enthalpy is given to you. Okay, we write the reaction. C4H10 is butane combined with oxygen, give you CO2 and H2O. You need to be able to balance it with these numbers. Since this is a molar enthalpy, I need to enthalpy for 2 mole. Just simply multiply this one by 2 to get the enthalpy. And you can just write that at the product side because its energy is exothermic, its energy is released. Or just put delta H at negative 570, which is negative means it's release, energy release. Write thermochemical equation to represent the dissolving of 1 mole of silver nitrate in water. The molar enthalpy is given. So you just write the equation, then see for 1 mole. So you have 1 here. So you just simply, this is multiplied by 1, give you the enthalpy here. So this absorbing 22.6 kilojoule to ionize. Method 2, when you have this enthalpy written beside your reaction equation. So this is a reaction equation. Delta H means this much of energy is released because it's negative. Here's another one. If you divide each term by 1/2, you have to divide the delta H by 2 as well, right? Because delta H divided by 2 is that. So every term here you see is divided by 2. Now looking at this question, sulfur dioxide and oxygen react to form sulfur trioxide. The molar enthalpy for combustion of sulfur dioxide we want in this reaction, is given. The molar enthalpy is given negative 98.9. What is the enthalpy change for this reaction? So here's 2 mole of SO2 is reacting. And here's molar, means you just multiply. This is for 1 mole. Molar enthalpy means for 1 mole. For 2 mole, you just simply multiply this one by 2. They did, and then you can write it down, the reaction, and put the delta H beside that. Here is another example, right? Came out a thermochemical equation for exothermic reaction between the oxygen and gas and the fluorine gas, that will give you tetraoxygen. So you have this reaction. The molar enthalpy is 251 kilojoule per mole. We just so have that. Since you have for 1 mole, then you balance it. You have 1 mole here. Just knowing that for 1 mole is just 251 kilojoule. If you release, you need to put negative here. The third method is, oh, you don't need to balance them. Okay, so here maybe we note that molar enthalpy delta is the energy change associated with a reaction of 1 mole of the substance that we talk about. A standard molar enthalpy is energy change associated with a reaction of the 1 mole of substance at a standard pressure and temperature. The standard pressure is 100 kilopascal and the standard temperature is 25 degrees. And we put a star on top of that. We put like a 0 on the top. This is a standard. And here is the question. Write an equation whose energy change is the molar enthalpy of combustion. So you just combustion of that, that's just reacting with oxygen, give you CO2, H2. You need to be able to balance it. Okay. At SATP, yeah, just saying that, write the reaction. An equation of whose enthalpy changes molar enthalpy of reaction calcium. So calcium with HCl give you H2 and stay CO2, and then you can balance it. Okay, here is the fourth method is using diagram. So when it's endothermic reactant is above, the product is lower, and it's showing the energy release. When it is endothermic, the reactant is lower than product, means energy is absorbed. Here is the example, Mg plus half O2, you just put it as a reactant, and Mg is going to be your product, exothermic, delta H of this reaction, you write it that. You need to be able to draw this if it is asked for. Same thing for endothermic, H2 is here, H2 and O2 there is going to be absorbing 285.8 kilojoule. So for the, you can do question number 2 and 3, this is page 319.